This is the final and last part of this lecture, and we are going to start from slide number 16 and going toward the slide number 23. And the topic is lab PCs, LEDs and switch boxes. Our labs have attached an IO box to the PCs, 5 LEDs, each may be either on or off, 5 switches, each may be either on or off. LEDs are connected to bits of an 8-bit output parallel port. Each LED is driven by a particular bit in the port. Let's move to the next slide. Programmer's model for the lab LEDs. LED data address E0101H bit configuration. LEDs are labeled from 1 to 5. Bit 7 is equal to most significant. Bit 0 is equal to least significant. There are bits, and this is LED. 1 through 5 indicate bits for LEDs, and X indicates unused. To turn LED on, set bit associated with LED, write an 8-bit value to the port in which bit associated with the LED is 1. To turn LED off, clear bit associated with LED. Programming the LEDs. We can also program the LEDs. Challenges. The LED's interface is a 8-bit port. Although we want to set and clear a particular bit, we must write an entire byte to the LED port. Writing any value to the LED port affects all LEDs. To modify the state of one LED, we must know the state of all LEDs, but reading port is meaningless. And let's move to slide number 19. Next slide of programming the LEDs. To manipulate the LEDs individually, the program must maintain the state of LEDs as a variable and update the variable each time a new value is written to the LEDs. So what is always represent the current LED state. Okay, and there's a question for you: how do you initialize this program? And you will answer this question in the comment section. Lab switches. The 5 switches on the IO box are connected to 5 bits of an 8-bit input parallel port. Okay, there's an 1 bit per switch. It is a read only port but used to get current settings. So if the switch is on, its byte is set to 1. If switch is off, its byte is clear to 0. The switch is labeled A and E. Switch debouncing. Debouncing is a mechanical device moving the switch position, open or close a switch. Switches have metal contact that will complete the circuit when joined. You can also see there the switches in the lab are spring model to hold and open and close the position. Okay, what is debouncing? The program must filter out the oscillation so that the program only sees and switch state change per position change. This is called debouncing. Simple debouncing. Write a loop that pull the switch until first change is seen. Waste enough time until sure switch stop bouncing. Question: how much is enough time? What if the program waits longer than necessary? What if the program does not wait long enough? And this is the last slide. Adaptive debouncing. In a loop, poll the switch until the first change is seen. Set a loop counter to an init value. This is the code, and explain. There's a question for you: explain why this approach is adaptive. Remaining issue: decide on the init value. Hope you like the video and subscribe our channel. If you have any query, then comment below and watch the previous videos as well. Thank you.